cheery topic of the bubonic plague. Who said economists aren't fun-loving? So here's the issue, and you're told at the beginning of the question that the title of the question, that this is going to have to do with the law of diminishing returns. So here's the story. During the 14th century, the bubonic plague reduced the population of England by approximately 1/3 in 3 years. A lot of people died. Historians report that afterwards the prices of goods rose, but wages, that is the incomes of the survivors, rose even more, resulting in higher real incomes for the survivors. Incidentally, the medium of exchange at the time was mainly metal coin, and the stock of metal coin was approximately the same before and after the plague. It turns out the bubonic plague doesn't eat gold. So, you gotta see the humor in this. Pardon, what effect did the plague have on total, not per capita, but on total output in England? Well, think about what's happened here, right? The amount of land and other capital inputs to production is the same. The total amount of labor has gone down by a lot due to the plague. Total output falls. So total output falls. There are fewer workers to work the land. So with less labor input, the total output falls, assuming that the marginal product of labor is positive, which it certainly is. Part B, explain why the prices of goods would be expected to rise. Well, the total output fell, but the stock of money remained the same. And the amount of metal coin that the remaining survivors have was the same as the total amount of coin before the plague. So what's happened to the marginal value of goods relative to the value of metal coin? We've got fewer goods being produced, the level of metal coin is the same, so the relative value of goods to metal coins has gone up. So the marginal value of goods relative to money rises. So that's why prices are higher. Part C, only humans caught the plague. Using the law of diminishing returns, explain why real incomes would increase. Well, since the plague affected only labor inputs, after the plague, there was a smaller amount of labor applied to the same amount of other inputs, principally land. Right? This is an agrarian economy for the most part. By the law of diminishing marginal productivity, the marginal product of labor increases. Right? If you've got less labor working with the same amount of other inputs like land, the marginal product of labor is going to increase, as does the value of the marginal product. And consequently, so do wages. Remember what determines wages in a market economy. In a market economy, wages are going to be equal to the value of the marginal product. So we have the marginal product increasing, the value of the marginal product is increasing, wages equal the value of the marginal product, so wages are higher as a result of the plague. So this wasn't part of the question, but I mean essentially what's going on here is that if you were a survivor of the plague, you were better off, other than the fact that you may have lost some loved ones, but your wages were higher. I'm not suggesting the plague is a good thing. The second question, non-renewable resource extraction. You are not responsible for this material. We are not going to discuss the answer to this question. Question 3. Question 3 gives you information on a labor input and the quantity of output at a smoothie business. So Kaiser produces fruit smoothies. The market for smoothies is perfectly competitive, and the price, the equilibrium price, is $4 a smoothie. The labor market is competitive, and the wage rate is $40 per day. The following table shows the relationship between the amount of labor L employed and the quantity of smoothies produced at Kaiser's each day. So here's the information that you're given here. So the first part of the question says, calculate the marginal product and the value of the marginal product for labor. So what is the marginal product of the first worker? 7. what's the marginal product of the second worker? Well, we go from 7 to 21, that's a difference of 14, so that's the marginal product of the second worker. The marginal product of the third worker, 12, we go from 21 to 33, etc., etc. So notice here, after we get to 2 workers, the law of diminishing marginal productivity kicks in, and marginal product starts declining. The value of the marginal product, how do we compute that? What was the price per smoothie? $4. The value of the marginal product is the marginal product multiplied by the output price. So I'm going to multiply this marginal product column by 4. I get 28, 56, 48, 40, 32, 60. So that completes part A. The next question is, at an output price of $4 a smoothie and a wage rate of $40, how many workers will Kaiser hire to maximize its profit, and how many smoothies per day will Kaiser produce? How many workers? 4, right? You keep hiring workers as long as the value of the marginal product, which is the additional revenue you're bringing into the firm, is greater than the wage. So in particular, the wage is $40. So as long as the value of the marginal product is greater than the wage, you keep hiring workers. You stop once you get to this point. How many smoothies are therefore being produced each day? 43. Part C of the question. You're told that there is a 50%, because of the installation of the machine, that the productivity of workers has increased by 50%. If the price remains at $4 per smoothie, but the wage suddenly rises to $48 a day, how many workers does Kaiser hire? There are a couple ways of answering this question in terms of modeling the 50% increase in productivity. You can either sort of start from scratch and multiply total output by 50% by 1.5, or you can work directly with the marginal product and you'll get the same answer. So that's what I've done here. So if I multiply this marginal product from the earlier table by 50%, what do I get? I get 10.5, I get 21, 18, 15, 12, and 6. So all I did was take this marginal product row and I multiplied it by 1.5, which represents a 50% increase. So here is now the new marginal productivity. You're told, by the way, that the price of smoothies remains the same, but the wage is now $48. So, how many workers does Kaiser now hire? You could fill out the value of the marginal product column. Let me just jump straight to the answer here. The key is going to be that when you fill out the value of the marginal product row, you're going to find that the value of the marginal product of the fifth worker is now $48. $48 happens to represent the new wage rate. The firm maximizes profits by hiring workers to the point where the wage rate equals the value of the marginal product. So Kaiser now hires 5 workers. Next question. What is the Coase theorem? What assumptions must be satisfied for the Coase theorem to be applicable in resolving externality problems? Now you didn't have to use, to get full credit, you didn't have to use exactly this wording, but the Coase theorem is the proposition that in the absence of transaction costs and with clearly defined property rights, the assignment of liability to damages created by one individual will not prevent the exhaustion of mutual benefits. That is, bargaining between folks affected by an externality can restore economic efficiency. Let me point out again, though, for the Coase theorem to work, for this kind of private bargaining to, in fact, restore economic efficiency, it requires zero or very minimal transaction costs. Right? So the Coase theorem, by the way, just let me go on and talk a little bit more about it. The Coase theorem is basically an argument that says we don't necessarily need the government to intervene every time there's a negative externality. As long as the government clearly defines property rights, we might expect people to bargain their way to the efficient level of the externality. This, however, requires zero or very minimal transaction costs. My problem with the applicability of the Coase theorem to resolving, for example, our major pollution problems is that if you think about most major pollution problems, which is an example of a negative externality, the transaction costs are not likely to be very small. If you think about all of the people that are negatively affected by pollution, getting those folks together and sort of collectively bribing the perpetrator of the externality is not very likely to happen. And the government might be able to restore the appropriate level of the externality at lower cost through regulation. This is not to say that the government always does a very good job of regulation, but that's another issue. Anyway, standard definition of the Coase theorem presented in Chapter 9. You can look up the definition in the index, or the glossary, I should say, of the textbook, and you'll see it's a definition similar to what I just read. Imperfect market structures. A, monopoly. For the following questions, assume the good in question is homogeneous and that the market demand function is 25 minus 0.25 times P. And therefore, if you were to rearrange this algebraically, that's the same as saying that P is equal to 100 minus 4Q. For the monopoly problem, you were told that the monopolist has marginal costs that are a constant $20 per unit, and that marginal revenue, remember, if you have a straight line demand function, marginal revenue is also going to be a straight line with twice the slope. So in this problem, we find, of course, the monopolist maximizing profits by equating marginal revenue and marginal costs. So if you solve that equation, you find the monopolist produces 10 units of output. To calculate the deadweight loss, again, we have to compare that output level to the economically efficient output level, what I've called Q star. So if I equate price and marginal costs, you find that the economically efficient level of output is 20, not 10. The deadweight loss is therefore given by the area of a triangle. The monopoly price, by the way, is 60. If you plug a quantity of 10 back into the demand function, you find the price is equal to 60. So that's the monopoly price. That's the competitive price of marginal cost, $20. And the difference in output levels is 20 minus 10. The deadweight loss to monopoly in this problem is therefore $200. The next question. Duopoly. Suppose there are two firms in the industry, each with constant marginal costs equal to $20 and no capacity constraints. Suppose further that the two firms will compete against each other just once in this market. Again, this is the Bertrand model. And part A is the same as part A in that previous midterm. What is the Nash equilibrium to Bertrand's original model without capacity constraints? And the answer is price equals marginal cost. Each firm charges price equals marginal cost, which you're told in this problem is $20. Part B, you're told that each firm can only produce at most 15 units of output. So the question is, does 15 units of output represent a binding capacity constraint? And to answer that question, we need to figure out, at price equals marginal cost of $20, how much would consumers be willing to purchase? Remember, in this problem, you're told that price is equal to 100 minus 4Q. If I plug in price equals 20, I can compute how much consumers would like to purchase. So in this problem, at price equals marginal cost, this is a different demand function than the previous midterm question, or final question we already looked at. You find that consumers would like to purchase a total of 20 units of product if price were as low as 20 bucks, if price was equal to marginal cost. In this problem, then, does the fact that each firm can only produce 15 units of product, does that represent a binding capacity constraint? And the answer is yes. So do we get Bertrand's result of price equals marginal cost as the Nash equilibrium to a pricing game? And the answer is no. That is, if your rival was charging price equals marginal cost, if your rival in this problem was charging $20, is there something that you could do that would generate positive profits? Because after all, if your rival is charging a price of 20 bucks and you charge a price of 20 bucks, what profits would you make? Zero. So the question is, could you do something other than charge price equals 20 bucks and make a positive profit? And the answer is yes. If you charge a higher price than $20, what's going to happen here? If your rival's charging $20 and you're charging something like $25, let's say, all of the consumers are going to run to the other guy, the rival, and they're going to try to purchase what they want at a price of $20. But what happens here? We have a binding capacity constraint. Only 15 units can be sold to those customers because of the binding capacity constraint. Some of those consumers aren't going to like it that they weren't able to purchase from the lower price firm, but some of those consumers might be willing to pay you the higher price that you're charging. To the extent that you sell anything at a price above marginal cost, above $20, you're now making a positive profit. Well, both firms, of course, realize that this is the case. And so price equals marginal cost will no longer be the Nash equilibrium. When you have binding capacity constraints, the Nash equilibrium in a Bertrand-style pricing game is going to be at a price above marginal cost. Right? We can't, with the information provided here, we can't predict exactly what the outcome is going to be, but you didn't have to. To get credit for this question, you simply had to note that 15 represented a binding capacity constraint. Therefore, the firms have an incentive to charge prices in equilibrium that are above price equals marginal cost. Any questions about those answers at all? Yeah. You speak up. A cost function? Sure. A cost function measures the minimum dollar cost of producing a certain amount of output. So if I have a valid cost function for a firm, it's a function of Q. The argument of the function is output, units of output. If I have a valid cost function for a firm, it's a functional form where when I plug in Q, what comes out of the function is a dollar amount, the minimum dollar cost it's going to take to produce Q units of output. So to be economically efficient, a firm has to be operating according to its cost function. If they're not minimizing the amount of money that it takes to produce Q units of output, they're not being efficient. They should operate according to their cost function. Other questions? You will find on the class website that I have posted a list of review topics for the final exam. So there are topics mentioned from Chapter 6, Chapter 7, Chapter 8, the first 4 sections of Chapter 9. We skipped Chapter 10, Chapter 11, Chapter 12, and we, of course, skipped Chapter 13, Natural Resources. So, if you haven't done so already, please do the last My Econ Lab assignment having to do with Chapter 11. On Tuesday, the final exam is at 10:30. Please try to get here at least 5 minutes early so we can get everybody settled in and you'll have the full amount of time to do the exam. Okay? Have a nice weekend.